Hello everyone, and welcome to this audio podcast. This audio podcast is part of an erythropoiesis edition. This is an audio podcast as part of Hurricane Plexar. This is an audio podcast as part of the meteor storm. And this is an audio podcast as part of a storm robotics production. This audio podcast, this audio podcast, this audio podcast will be sort of an intermission, between the end of this particular series, but then but also a sort of an intermission, sort of that links into part of into sort of part of the in as part of the audio podcast series as sort of that will be a part of another series so this audio podcast intermission will audio podcast intermission will go into something that is in regard to into a particular immunobiological aspect, and in particularly focusing on what's referred to as the CXCR3 chemokine receptor. So CXCR3 chemokine is an interferon inducible chemokine receptor expressed on various cell types, but preferentially on monocytes, TH type 1 T cells, CD8 T cells, natural killer T cells, dendritic cells, and some cancer cells as well. Homeostatic proliferation of T cells in immune depleted individuals can also lead to an enrichment of CXCR3 positive T cells. The CXCR3 receptor reacts with three interferon inducible chemokines. So the chemokines or additional chemokines where CXCR3 sort of has interplay with or interacts with include CXCR9, which is and can be referred to as MIG, CXCL10, which can be referred to as IP10, and CXCL11, which can be referred to as ITAC or IP9. In addition, where CXCR3 receptor, the CXCR3 receptor also interacts or interplays with CXCR4. The main sort of chemokine ligands or the main chemokine ligands of CXCR3, CXCL9, CXCL10, and CXCL11 have limited expression under homeostatic conditions, but are rapidly upregulated by chemokine stimulation. So in around some sort of bases in around sort of chemokine superfamily. So chemokines play pivotal roles in physiological processes of the immune cell maturation and trafficking. Chemokines sort of regulate inflammatory processes by inducing, maintaining, and amplifying inflammatory and immune reactions. And two classes of chemokines have been evidence in some depth in sort of the scientific literature, if you like. There's the inflammatory inducible chemokines, and the homeostatic or constitutive chemokines. Inflammatory chemokines are involved in the direct recruitment of effector leukocytes at sites of inflammation during infection, in tissue injury and tumors. The homeostatic chemokines control sort of lymphocytes and dendritic cells or DC cells or dendritic cells, and sort of dendritic cells and trafficking, and are involved in immune surveillance as well. Dual function chemokines participate in immune defense functions, and target non-effector leukocytes. Here is a sort of a representation, really, a representation in context of chemokine receptor expression in line to in around solid organ transplantation. So this sort of illustration sort of depicts, really, where, for example, where there's chemokine receptor or varying types of chemokine and chemokine receptors, and also sort of where the chemokine receptors are important in context of their sort of duration. So, for example, at 1 hour post engraftment in line to transplantation, you have, for example, you have different varying cells. So, for example, neutrophils, natural killer cells, monocytes, and macrophages, and effector T cells. And at 1 hour, for example, you have at the bottom part of the graphic, or the figure, of the illustration. There is the neutrophils. With the neutrophils, you have CXCR1, 2, and 5, and you have CXCR1 and 2 at 1 hour. Sort of post transplant, and then at 1 to 2 weeks, or sort of between 1 hour and 1 to 2 weeks, you have natural killer cells, which include CCR2, so chemokine receptors 2, 5, and then CXCR1, 2, 3, and 6 expression. And then between 1 hour, 1 to 2 weeks, and then 1 to 2 weeks to 2 to 4 weeks, so up to a month post transplant, you have cells, for example, monocytes and macrophages, CCR1, 2, and 5, CXCR1, 2, 3, and 6, and then at the same time, you have effector T cells, so where you have a TH or T helper cell type 1, CCR5, 6, and CXCR3 expression, and then you have T helper cell type 2, CCR3, 4, and 8. And then you have T regulator cells, or Tregs, which T regulator cells, and then you have CCR chemokine receptors, CCR4, and also CCR8, and then later you then have CCR1, more CCR1 expression, and 2 and 5, and then you have have more CXCR3 expression, CXCR3 and CXCR4 expression. And so, and then at the top part of the graphic, where you have chemokine expression. So, at the top part of the graphic, you have sort of the early phase, 1 to 72 hours, and then you have acute phase between 2 to 30 days, and then you have a chronic phase, sort of 2 weeks plus. So in the first 72 hours, sort of post engraftment, you have a range, sort of a varying sort of chemokines and chemokine receptors being sort of involved in the in part of the immune response, and notably uh, for example, between the first up to 72 hours and up to 2 weeks, and between the different phases, and the top part of the graphic, and notably CCL1, CCL1 and 5, CCL1 to CCL5 are is pretty much involved across the three across the across the different different phases: the early phase, the acute phase, and the chronic phase. And at the same time, there is literature going back to the early in around 2000, between 2000 and 2003, which highlight quite nicely where investigators have looked at how different chemokine receptors are chemotactic for different chemokines. Chemokine receptors are chemotactic for different ligands. And so the L sort of aspect, the L aspect on the expression is, or where the expression is stands for, generally stands for the ligand, where there's a ligand, and where and at the bottom, on the bottom part of the graph again, on the graphic again, you have where you have, for example, where you have denotion of R. The R denotion refers to the receptor. So at the top you have sort of ligands, if you like, and then you have at the bottom you have sort of the receptors. But at the same time, the graphic generally shows, or generally sort of hopefully depicts, basically which cells or which cell types are sort of have been investigated and are sort of pivotal across sort of the early transplant phase, early sort of transplant phases, once an allograft has been inserted into patients or into recipients for an aligned to transplantation. So, in following then, a little bit more about the immune response. So the inflammatory processes during organ transplantation and rejection are complex and constitute sort of a multifaceted network among organ resident cells, infiltrating cells, cytokines, and molecular mediators contributing to injury of the allograft, injury of the allograft or the graft. The injury to the graft is mainly due to the graft infiltrating T cells that produce a response which directly or indirectly affects recipient allograft function. And then at the same time, you have macrophages and neutrophils. So macrophages and neutrophils at the same time are sort of important hematological components. And these are important in where they are induced to produce toxic molecular mediators. At the same time, the expression of immune-induced chemokines, so for example CXCL10, 9, and 11, and receptor, the receptor, one of the most most sort of cited receptors in context of and around transplantational transplant immunobiology works, is CXCR3 is upregulated. And so once organ transplantation of allografts induce a sort of a vigorous anti-donor T cell response, which is initiated by the migration of dendritic cells from the donor organ to the recipient spleen, or around around the spleen. So in the spleen, at the same time, anti-allograft T cells migrate to the allograft, to the graft or allograft, where there is an activation, an activation to express effector functions. So, for example, cytolytic activities and cytokine production. So, in part of this, as well, a little bit around the ligand CXCL10. So CXCL10 has dual function in around as part of a CXC chemokine. CXCL10 has the property of being induced by FMY or FN gamma or FMY with CXCL9 and CXCL11. CXCL10 is also a potent chemoattractant for various immune cells, such as activated T helper cell type 1, natural killer cells, dendritic cells, and macrophages. It is also secreted by immune cells such as leukocytes, neutrophils, eosinophils, and monocytes. And non-immune cells, so for example, epithelial, endothelial, keratinocytes, and stromal cells. Enhance CXCL10 production in an allograft, or in circulating blood of organ recipients or organ transplanted recipients is also associated with its increased concentration in specimens. So, for example, in serum and in plasma. Here is an illustration to sort of highlight the varying activities around CXCL10. So where there is a link, for example, with CXCL10, and where there is a basis in around CXCR3, and also where CXCL10 again in a murine laboratory model highlights sort of where T helper cell types 1, natural killer cells, and monocytes are involved. And so, at the same time, CXCL10 is had been one of the first ligands detected after transplantation or post-transplantation, post-transplant of and following sort of engraftment. There have been an observed association between CXCL10 expression and acute rejection of renal in around renal transplants. Higher expression of CXCL10 might predict or had been evidenced as where there may be a prediction about in around CXCL10 titers, and where the titers could in around CXCL10 could help predict graft or allograft loss at 1 year post-transplant, and confirming the fact that a higher intrarenal chemokine expression is a high risk for premature graft loss. And at the same time, in around inflammation and chemotaxis. So chemotaxis is sort of a terminology. If those are listening on this audio podcast, is to inform that chemotaxis is terminology used to see the migration of certain chemokines to produce a specific response. So CXCL10 have been identified as a pro-inflammatory chemokine that mediated leukocyte trafficking and modulated innate and adaptive immune response and responses. Inflammation is also a biological response to harmful stimuli, and it is a protective sort of attempt, really, by a host to remove pathogens or damaged cells. Inflammation is associated with the secretion of CXCL10 from inflammatory and non-inflammatory cells in response to interferon gamma. And CXCL10 at the same time acts as a powerful sort of chemotactic factor for the recruitment for T helper cell type 1 or T helper cell type 1 cells, and as part of an inflammatory response. So in around allograft rejection, as I mentioned, this sort of intermission. This intermission sort of audio podcast sort of links in to into sort of a sort of anticipated audio podcast series as well. So a little bit in around allograft rejection as part of this. So despite the significant sort of significant advances in around pharmacodynamics. In around pharmacotherapy and pharmacotherapeutics, for example, and in particular in around immunosuppression, acute allograft rejection or acute rejection remains a crucial hindrance or a barrier to long-term prognoses. Acute rejection of a renal allograft has sort of clinical features such as sort of, for example, fever and oliguria, where recipients unfortunately owing to where renal insufficiency insufficiency occurs, oliguria can be part of the symptomology where recipients may not be able to micturate or have the sensation of wanting to, for example, for the sort of sensation of wanting to void, but also oliguria is where unlike, for example, anuria, is where oliguria is a sort of a complete hindrance to the ability of the urinary tract opening and where recipients cannot void, and anuria is where just as a basis is where recipients can have the sensation to void and can void, except with voiding or an attempt to avoid, there is little ability or capacity where glomeruli, the functional components in around the glomeruli and the nephrons and the functional components of the kidneys have the ability to rid of the appropriate sort of toxins from the blood. And therefore, there is ischemia and reperfusion injury post-transplant is also marked by accumulation of neutrophils and monocytes. And acute rejection characterized by recruitment of T cells, natural killer cells, and macrophages, followed by tissue injury can be pivotal. Chemokines also affect all phases of injury by regulating leukocyte recruitment and inflammatory responses. Chemokines also have been identified and established through histological findings in around, for example, investigations such as renal biopsies or biopsies. A number of chemokines and receptors in human renal transplantation have also shown an increased expression in acute allograft rejection. A heightened expression of various immune cell components in peripheral blood leukocytes also correlate with acute allograft rejection. So a little bit around biomarkers as well. So peripheral biomarkers have been under some intrigue and investigation to determine both pre and post transplant immune status of an organ transplanted recipients in order to predict and sort of detect acute and or chronic rejection. In the audio podcast sort of ahead, there will be some more depth in around some of the bases of acute rejection and chronic rejection. However, at the same time, evidence has shown in the literature that there is an association between levels of interferon gamma, inducible protein CXCL10, and the inflammatory immune processes occurring during allograft transplantation. Biomarkers for assessing a patient's or recipient's pre-transplant immune status may be helpful to also tailor immunosuppression to help also monitor the balance between rejection risk and therapy in order to minimize drug side effects. So, for example, nephro, again, sort of where the sort of prospective audio podcast series will delve into aspects around nephrotoxicity and looking at sort of those aspects that are important in around that. A little bit around Luminex, in around a Luminex assay, which has been important in sort of more recent in some recent advances in aspects around laboratory and pathology medicine. So determining, for example, MIG or CXCL9, IP10, CXCL10, and ITAC CXCL11 levels using Luminex assays may offer a sort of a non-invasive means to diagnose T-cell mediated acute rejection in renal allografted recipients. It is a high throughput tool which high throughput sort of assay which detects numerous chemokines and cytokines in small amounts, and where only small amounts of serum are required. The joint detection of MIG the joint detection of MIG, IP10, and ITAC in serum using Luminex analysis may constitute also a sort of non-invasive and efficient modality for the early prediction of T-cell mediated acute rejection in around solid organ transplantation, where for example again sort of MIG, IP10, and ITAC are also important ligands in around for example other solid organ transplant sort of specialties as well. And so CXCR3 and its ligands, for example MIG, IP10, and ITAC may also be reliable biomarkers for T-cell mediated acute rejection as well. The detection of MIG, IP10, and ITAC in the serum is also easier. Is sort of a more easy and an efficient and a more efficient a more efficient modality compared with the determination of CXCR3 CXCR3 alone on particular cell surfaces. A little bit now around CXCR3 antagonists. So murine laboratory models lacking CXCR3, where murine models are deficient in CXCR3, have been shown to tolerate mismatched cardiac allografts for extended durations. Positive effects of small molecule CXCR3 blockade on allograft survival prognoses was and have been investigated in a variety of transplant transplant models. A blockade of CXCR3 by compound MRL and 957, where the compound there's a compound MRL and 957 is another important component and biomarker, and resulted in a moderate increase in allograft prognoses. Administration of CXCR3 antagonists to allograft recipients prolonged allograft prognoses with short-term and low-dose co-stimulatory blockade. The small molecule antagonist TAC779 had been described as a CCR5 CXCR3 antagonist and had demonstrated efficacy in several in vivo investigations. Data from retrospective investigations have also highlighted promising CXCR3 antagonists and are well tolerated and achieve sufficient levels of blockade. The complex pharmacology, however, of CXCR3 may provide opportunities for an unbiased approach to antagonism, with the potential for greater efficacy and selectivity. So, in summary, as part of this intermission, is CXCR3 chemokines are strongly associated with T helper cell type 1 cell trafficking during the immune response in allograft rejection. The detection of and quantification of CXCL10 in fluids may be a useful tool for monitoring of the inflammatory status of organ transplanted recipients and positive outcomes. CXCL10 and CXCL3 interactions or interplay appear to play an important role or have an important role in the pathogenesis of allograft failure and rejection in multi-organ specialties and in laboratory models. The detection of CXCR3 ligands in the serum using Luminex analysis or Luminex assays may be a non-invasive and efficient modality for early stage prediction of T cell mediated acute rejection. The detection of MIG, IP10, and ITAC in the serum of recipients may constitute a method for diagnosing acute rejection episodes after transplantation or post-transplantation. And despite CXCR3 antagonists at present failure in clinical trials, CXCR3 antagonists at the same time have shown efficacy in animal models around the human disease, in around varying human diseases, varying human diseases around renal pathophysiology. So thank you for tuning in on this audio podcast. This audio podcast has been as part of the Erythropoiesis edition. An audio podcast as part of the Hurricane Plexar, audio podcast as part of the Meteor Storm, an audio podcast as part of a Storm Robotics production, and an audio podcast where this this intermission is part of a Storm Robotics collaborative. Thank you for tuning in.